Hello students, welcome to today's session on friction from the unit laws of motion. And this is second one of the most challenging and academically relevant topics for both CBSE boards and competitions. So one of my questions is, most elementary question is, why are we able to walk if friction exists? Okay. Second, what prevents us from toppling or slipping? So it's where perspective comes. Okay. Perspective makes a scenario positive or negative. First, in the first case, why are we able to walk? We are able to walk because friction is existing, but friction is a self-adjusting physical quantity of physics. What is it? Yes, self-adjusting. You can very evidently find it in your NCERT textbooks. Friction has self-adjusting phenomena. If you are providing 2 Newton force, the friction will be 0.2. If you are providing 9 Newton force, that 0.2 will getting an increment of, let's say, 0.9 or 2 or 3. It varies. It depends upon other factors too. But yeah, for first upon the applied agency, which is the force which we are applying. So we are able to walk only on the spur of friction, because there exists friction, there exists a resistive force between our shoes and the surface, which is also allowing us to stand on the surface. Because if we were given a condition where we are completely frictionless, we would have slipped upon the surface. So friction is a boon to us, and that's what prevents us from slipping. But if also on that particular note, I would like to remind you that if the frictional force, the value is more than mg, the person is not walking. Just the case of a tire of a car, not of a person. A car tire with, let's suppose, jammed left wheel. There the mg, that means maybe this is the mass of the car, or this is the normal reaction of the car, and the car wheel and the car tire is somewhere, let's suppose, 375 Newton of force, which is a very less force. That means $5,000 is more than 375 Newton. The car will not move. Newton being the unit, SI unit of friction. Yeah. So enough amount of force should be applied on the wheels to overcome the resistive force so that the car could move, the car could see the motion. Static friction. Static friction prevents the motion basically. There are various kinds of phenomena. We can see one of the phases which is static versus kinetic friction. Static friction adjusts itself. It prevents motion. Kinetic friction is a constant quantity. It opposes sliding motion. Static friction is equals to mu s times n. That means the coefficient of coefficient of static friction times n, which is the normal force. So mg and fk, that is the kinetic friction, is equals to coefficient of kinetic friction times n. Okay. And usually there is a keynote students to note that mu k, the value of mu k is less than mu s. Usually, and it's a very key point to note. Let's take an example of static friction and kinetic friction. Place a book on the table. Push lightly. Book does not move. When you consider the same example and we repeat the steps, but we push harder, the book moves. The book is moving on spur of kinetic friction. It's not moving on spur of static friction. That's the difference. So the value which is allowing it to move has to remain a constant because it's beating up a threshold value. Okay. So the threshold value, which is self-adjusting, is not a constant and henceforth static. And on the contrary, kinetic. Those are the differences. Then we'll be considering angle of repose, which is an increase in the angle, or theta, where theta is equals to tan inverse mu times, where a block slides while placing on an inclined plane. This is block, this is A block, and this is an inclination of that surface. Okay, let's consider one of the examples. Quite relatable and quite logical, less conceptual topic, friction. A block of mass 2.5 kg is kept on a rough horizontal surface. It's found that the block does not slide if a horizontal force less than 15 Newton, that means static friction, is applied to it. Also, it's found that it takes 5 seconds to slide through the first 10 meters if a horizontal force of 15 Newton is applied and the block is gently pushed to start the motion. Okay. Taking G to be 10 meter per second square, we are calculating both the coefficients. We are framing the equations F is equal to mu s times N, where N is equals to mg, putting up the values, finding mu s to be 0.6. In the second case, we are using one of the laws of equation, laws of motion basically, coming from the rectilinear motion, S is equal to ut plus half at square, where u was 0, so it became half at square. And we have calculated acceleration to be 0.8 meter per second square. Then frictional force is F is equals to mu k times N. We are calling for the kinetic friction and mu k times mg. Applying Newton's second law, F is equal to mu k mg is equals to ma, where mu k is equals to F minus ma upon mg. We are substituting, and then the grade 10 mathematics we are applying, finding the answer to be 0.52 on spur of substituting the correct values in the expression form. 0.52 remains to be the answer. Such kind of conceptual questions will be asked. The logic will be of grade 10, but the concepts are of grade 11. So that is the, coherence of friction and kinematics today. Thank you so much, students. I hope you all understood the topic. Keep practicing, and I'll see you in the next session. Please revert to my Urban Pro profile if you face any queries and want to learn from me. Thank you so much.